So this unit is going to involve a lot of formulas. You guys get a formula sheet for your tests and exams, and identities, what we're doing, is going to make up a big part of it, okay? Because there's actually quite a few to remember, so that's why you're given the majority of them. I have given you a formula sheet with all the identities, but some of those will not be given on the provincial. I will tell you which ones. Okay, some you get, some you don't. You're going to have to remember. So what exactly is an identity? Well, it's a trig equation that's true for all values of the variable. Or they're trig expressions that are equal to each other. They're equivalent to each other, except any non-permissible values. Do you remember we've been doing, when we've been evaluating trig ratios, whenever you guys were asked to find the tan of some angle, you always did y divide x, right? Using the unit circle points. Well, wasn't y the sine of whatever that angle was? And x was always equal to the cosine? So this is an identity. The tan of an angle will be the same as if you take its sine and divide its cosine. Except whenever this works out to 0, because we can never divide 0, right? So what values of x would make cos x equal to 0? So we're finding, if you remember these from grade 11, the non-permissible values. Those are the values that will make the denominator 0. So what values of x, right? We're asking ourselves, what values of x will make cos x equal 0? Well, there's infinite values, but we only want to know the ones from 0 to 2 pi. Well, isn't this just a trig equation using the unit circle? What values of x, or what angles of x on the unit circle have an x coordinate of 0? Pi over 2 and 3 pi over 2. So we would say it one of two ways. We would say the non-permissible values are pi over 2 and 3 pi over 2. Or we could say it like this: x cannot equal pi over 2 and 3 pi over 2. So these are your possible answers. What's one way we can prove identities? Because that's going to be a big part of this unit, is we take angle measures and see if we find that in this case, if we take a 60-degree angle, will the tan of the 60-degree angle equal the sine of that angle divided by cos? And would it also work if it's pi over 4 radians? So what do? Here's how we set it up. And we're going to do a lot. We're going to do this a lot in this unit. Left side, right side. On the left side of the equation, I am trying to find the tan of 60 degrees. On the right side of the equation, I am trying to find the sine of 60 degrees, divide the cos of 60 degrees. Well, tan of 60 that's whatever the point on the unit circle that corresponds to 60 degrees, it's y divided x, right? So 60 degrees, what coordinate is that? 1/2, comma, root 3 over 2. So I got to do root 3 over 2 divide 1/2, which is root 3 over 2 times 2 over 1. 2's cancel, and I'm left with root 3. What's the sine of 60 degrees? Root 3 over 2. And I need to divide that by the cosine of 60 degrees.
Wait, sine is one of them. No, never mind. No, we're good. 1, 2.
So I have to divide those two. Well, it turns out to be the same thing. So we've just proven that the tan of an angle is equal to its sine divided its cos. Because when I picked an angle and evaluated it, I got the same value. So I can say the left side equals the right side. Question is, does that work for every angle, whether it's in degrees or radians? Well, let's try pi over 4. I'm going to do it the same way. So I need to find the tan of pi over 4. Then I need to find the sine of pi over 4 and divide that by the cosine of pi over 4. Will I get the same answer on either side? So pi over 4, y divide x. Root 2 over 2 divide root 2 over 2. Which we don't have to change for multiplication because we should recognize that as 1. And this one, well, the sine of pi over 4 is root 2 over 2. We're going to divide that by the cosine of pi over 4, which is also root 2 over 2, so it's the same division. And the left side equals the right side. But this gets very tedious. I mean, we would have to do this for every angle, and that would take forever. Okay. We do know that the tan is equal to the sine over the cos. We have actually already proven that. But you can use angles as examples to show that they're equal. Okay. So a big part of this unit, the main part of this unit, is we are going to prove that two expressions are equal to each other by using different formulas. That's the big part of the unit. But before we do that, we're going to have to be able to manipulate these expressions. So we're going to have to recall some algebra and then use it with trigonometry. Okay, so this is just kind of a review. I'm going to give you a couple of algebra questions. Okay, and then we're going to throw some trig in there with the same kind of questions. So, well, here we've got numbers. We should be already familiar with how to do this. All we do is change it to multiplication by inverting the second fraction. 4 and 2 cancel down to 2 and 1. And I get 2 root 3. You do the same thing if they were variables. Change it to multiplication. Do any canceling, the x's cancel. And I'm left with z over y. Well, let's throw in a couple of trig expressions. the method is still the same. How do you divide two trig fractions? Change it to multiplication. So this would be sine theta over cos theta times sine theta over cos theta. Well, what's sine theta times sine theta? Sine squared theta. And cos theta times cos theta obviously is cos squared theta. What is this equivalent to? Tan squared theta, right? We just learned that. If sine over cos is equal to tan, then sine squared over cos squared must equal tan squared as well. So that's dividing fractions. What about if we're adding or subtracting fractions? Common denominator. When we did these in grade 11, what's the common denominator of x and y? xy. What do I have to multiply this first numerator by to get this denominator? So I get 3y. Minus, what do I have to multiply this by? X. So I'm done. Can't go any simpler than that. What if instead of variables, we throw in trig expressions? Still the same. What's the lowest common denominator of cos theta sine theta? Cos theta times sine theta. Just multiply them together. What do I have to multiply this one by to get this denominator? Right, so really I'm just doing sine theta times sine theta. And that will get me sine theta up top. What must I multiply this one by? So that gives me plus no squared thing. And you've made it into a single fraction, so you're done. All right. This is what's called a complex fraction because it's fractions within a big fraction. So what I'm going to have to do some work here. Because I'm going to have to add these two up top into a single fraction. I'm going to have to subtract these into a single fraction, and then I'm going to have to divide the two answers. So what's the lowest common denominator of y and x? xy. So I'm going to write it xy to keep it consistent with this one. What do I have to multiply this by to get this? X, right? So x times the top is x squared. What do I multiply this one by? Y, right? Here, I'll show you. So that gives us plus y squared. And that's just the top. Lowest common denominator at the bottom, xy again. So this first one has to get multiplied by y over y. The second one has to get multiplied by x over x. So what do I end up with as my numerators? Y minus x squared. So I've got this fraction divide this fraction, which is equivalent to this fraction times the flip or reciprocal of this one. What would you do now? Cancel the xy's and then just put what remains into a single fraction. And we're done. Okay, that's sort of the most complicated we're going to get to. So now what we're going to do, what we're actually going to be doing in this unit is one like these, where it's not variables and numbers, it's trig. But the method stays the same. Okay? I've got to subtract these two into a single fraction, add these two into a single fraction, and then divide those two. Yeah.
Like I get why, but why do we cancel out the experience? Right?
Because remember,
Is that a whole?
yes, that's a whole expression that has to stay together. You can't pull out part of it to cancel. Yeah, no, that's a good question. The students will often do it. Okay, what's the lowest common denominator up top? Sine theta, cos theta. And therefore, I would have to multiply this first one, top and bottom, by cos theta. And this second one, I'd have to multiply top and bottom by sine theta. So what do I end up with up top? Cos theta minus sine squared theta. On the bottom, well, same LCD, lowest common denominator. You can write it cos theta sine theta, but I'm going to write it so it's consistent with the fraction up top. Which means I have to multiply the first fraction by sine theta over sine theta, and the second fraction by cos theta over cos theta. And what do I end up with up top? Okay. Now I'm going to change this, divide this into a multiplication. So it's going to be cos theta minus sine squared theta over sine theta cos theta times, flip the bottom fraction to sine theta cos theta over sine squared theta plus cos squared theta. Anything cancel? Those go. These can't, they're not identical. And we can't cancel part of it. So we end up with cos theta minus sine squared theta over sine squared theta plus cos squared theta. Okay. So these are the things you're going to have to be able to do with trig fractions, I'll call them. You have to be able to add them, to divide them, to multiply them, to subtract them. Okay? And when you do, you'll get certain identities, which is on the following page. Okay? These ones we have learned already. The cosecant theta is the same as taking sine theta and flipping it, which is what we're doing here. Sec theta is the same as taking cos theta and flipping it. And cotangent theta is equal to taking tan theta and flipping it. These are the ones you want to know. Okay? We rarely use this one. Like I would even cross it out. We rarely use this one with identities. We use this one for cotangent theta way more. Those are called the reciprocal. Why? Because they're reciprocals of each other. Cosecant and sine, secant and cosine. Quotient identities, well, quotient means division. And we've already talked about this one. Tan theta will always equal sine over cos. And cotangent will be the reciprocal of this, cos over sine. So you really want to know these ones. This one we have been doing for quite a while with the unit circle equation. Remember the unit circle, x squared plus y squared will always equal 1 in the unit circle. Well, what's x in trig? It's cosine. What's y in trig? It's sine. So instead of saying x squared and y squared, or y squared and x squared, I could say this. This is the one you really want to know. And you also really want to know these. These are what happens when you manipulate this. If I took cos squared theta over to the other side, I get 1 minus cos squared theta. I get this. If I took sine squared theta over to the other side, I get 1 minus sine squared theta, or this. Unfortunately, this is the only one you get on your formula sheet. The remainders, you do not. So, formula, need to know, need to know, and need to know. I put them on that sheet I gave you as a reference sheet, okay? Like those are the ones I've highlighted as these are the most important ones. Now, finally, you can get 2 variations of these to get this and this. If we took this and divided everything by cos squared theta, so sine divided cos is the same as tan squared. Cos divided cos is the same as 1. 1 divided cos is the same as c. So this is just taking this and dividing everything by cos. This one is taking this original one and dividing everything by sine. These ones you do get, but honestly, I rarely use them. I find the less the better. The less I have to deal with, the better. I mean, they can be used to prove. But this also can be used to prove in its place. So before you flip the page, flip back. Because do you see any way we could make this even easier using the page that we just went through? Isn't this that we just learned on the second page 1? So this thing is 1. So our answer actually can go even simpler. That's the kind of thing we're going to do. Okay? All right, I want to just do one more page. I want to do this one. And I'll jump into the actual proving on Friday. Okay. Here's a trig expression. I want you to write it using cosecant. Use the previous page as a guide for you. Do you see anything in the numerator or denominator that you could simplify? This is the same as, if you look on the previous page, sine squared theta. Right? That's a Pythagorean identity, we call them. How could I write this using cosecant? Cosecant, like 1 over sine is the same as cosecant. So 1 over sine squared theta is the same as cosecant squared theta. And we've changed it. That's it. This one. Given 1 minus cos squared theta over cos squared theta is equal to tan squared theta, determine the non-permissible values over from 0 to 2 pi, and then prove it is an identity. Well, to determine the non-permissible values, we make the denominator we see 0. Well, how do I get from cos squared theta to cos theta? Square root, and the square root of 0 is still 0. NPVs, I should say. So, what values of theta will make cos theta equal 0? And those are the NPVs. Pi over 2 and 3 pi over 2. So we got the NPVs. So we've done that. Now we have to take this expression and prove it's an identity. Is there anything that you can change in this? This top changes to sine squared theta over cos squared theta. And that's one of the identities. Sine over cos is equal to tan. So we're done. Because we've just proven it's an identity, because that's one of the identities we know, sine over cos. Okay? Don't worry about just this just yet. I'm going to talk about it on Friday. But I'm going to do a couple of questions here. These are other ways you can simplify. Because you're going to have to, basically what you're going to do is you're going to be given a trig expression on one side, a different trig expression on the other, and by a series of manipulations and identities, you're going to have to show that they're equal to each other. You're going to have to make them equal to each other. And different ways we can do that is by canceling things, by factoring, by multiplying, and other ways to simplify. So for example, how would you factor this? What kind of factoring would you use? Right? GGF. Quadratic.
No, GCF.
Thank you.
Yeah.
What is the GCF? What can I take out of these? Cosines. What am I left with?
Sine squared x and cos squared x.
Can I make this simpler?
One.
Yeah, this is one. It's one of the identities. So notice when we factored it, we created an identity that allows us to simplify this thing to just cos x. So instead of saying all this, I can narrow it down to this. How about if we multiply these two out? Here. Remember, when we square something, you've got to take the expression, parentheses and all, and multiply it by itself. We don't just square each one inside the parentheses. It's 4 multiplications. So, sine times sine. Sine squared theta. And then sine times minus cos is just minus sine cos with theta. Then on the inside, we've got minus cosine with the thetas. Be careful with this one. Minus times minus gives you a plus cos squared theta. Can you see any simplifying?
2 sine theta plus
2?
yeah. Isn't it? Oh, -2.
-2. Yes, I can combine these to negative sine theta cos theta. Yeah, don't these two become 1? Sine squared plus cos squared is always 1. So I have that. Final one that I want to do. This one is very rare, but I want to show it to you because sometimes it does come up. Okay, but it is rare. If you look at this one, you can't simplify it right now. You can't make, why can't you make this sign? Because it's not squared. It has to be squared, right? So I can't do that. But there is a way. There is something I can multiply by, and the result will be something I can simplify. And that's called the conjugate. Do you remember what that is? We learned that last year. Change the sign of the denominator. So if it's 1 minus cos theta, we're going to multiply by 1 minus cos x. We're going to multiply by 1 plus cos x, which means I have to do the same thing to the top. So what do I get up top? 1 plus cos x. What do I get on the bottom? 4 multiplications. 1 plus cos x minus cos x minus cos squared x. Well, these go plus and minus.
One cos plus cos x over sine.
Right. 1 minus cos squared x, that is an identity. This is kind of one of these, this is like what we would call a Hail Mary. When you're not sure how to simplify something, usually this is the way you go. Okay? We'll do one example of it. But for now, I just want you to be sort of familiar with the identities, familiar with the type of work we're going to have to do, like simplifying, adding, multiplying, dividing, and subtracting. Okay, factoring, conjugates, things like that. We'll start proving these things next class.